Rain1290 with you to bring you another weather analysis, a thunderstorm outlook specifically for July 1st, 2025. That would be the day in question. It could turn into an interesting day depending on how all of this works out together. So it's especially important for the morning of July 1st, but there are important implications for the afternoon period as well. So without delaying any further, let's do an investigation as to why this is. So stick around to the end of this video. There you'll actually see me drawing the target areas for thunderstorms as well as their trajectories. Okay, so let's start with our synoptic charts. So this chart shows us different pressure areas like high pressure zones, low pressure zones, and the associated frontal boundaries that are associated with low pressure areas, right? So this is a low pressure area and this is a high pressure area, and here's some frontal boundaries, a cold front, and this blue represented by this blue spiky line, and this red semicircle line represents a warm front. So this is for the evening, the late afternoon to evening of June 30th and heading into July 1st. So if I flip it to the next map, so this is 12 hours later. So now we're into the morning. So we're into the morning of July 1st, around 8 o'clock in the morning. And now you see this cold front has moved off to the east associated with that area of low pressure. And it's now affecting eastern Ontario to southern Quebec and upstate New York in particular, and areas to the southwest. So ultimately, this cold front, will be the driving factor for thunderstorm development, on top of a shortwave trough, which I'm going to show momentarily. Okay, so looking at our surface convergence map over here. So this is surface moisture convergence. It's measured in grams per kilogram per second. So the brighter colors represent the largest amounts of lift, as you might recall from previous forecast videos. And really what we're targeting are these yellows to ideally the reds and dark reds and greater. So we want to see how that warm front and the cold front, so we know those are located in southern Ontario at this point. So this is the pre-dawn period of June 30th. We want to check the pre-dawn period of July 1st into the afternoon. So let's zoom in to that time frame. We're starting to see these more sizable areas of lift along that convergence zone, the warm front in this case, as it starts to migrate northeast. Now let's go into pre-dawn July 1st. So this is pre-dawn July 1st, 2 o'clock in the morning, and you start seeing even larger amounts of lift, or a larger area providing heightened amounts of lift, surface convergence. So let's go further into pre-dawn. This is now 5 o'clock in the morning, and we're seeing these lift maxima that are taking place right over Lake Ontario and then farther northeast towards eastern Ontario and sneaking into southern Quebec and upstate New York. So I would expect this area to start becoming more and more ripe for thunderstorms to start taking place in this region, or these regions. Okay, and going forward in time, so we're also interested in the afternoon since we know that cold front is becoming more important as well. So we know the morning is more dominated by the warm front, especially pre-dawn, but as we start going later pre-dawn to the afternoon, the cold front starts to become more important. So let's do a little bit of an evaluation of our cold front. And yes, we're still seeing some heightened areas of lift in upstate New York, especially, and parts of southern Quebec, eastern Ontario. And this is still showing us some pretty sizable amounts of lift taking place during the early to mid-afternoon period. Beyond that point, thunderstorms are less likely to emerge since our frontal systems and our troughs will have evacuated off to the east. So stick around to the end of this video. There you'll actually see me drawing the target areas for thunderstorms as well as their trajectories. What sort of lift might be available to us in addition to the lift that would be provided by the warm front and cold front that we looked at in our synoptic chart and previously with our surface convergence. So here we're looking for any shortwave trough that can maximize lift, and right now we're seeing some indications of higher lift taking place to the west and moving east, northeast. And this is later June 30th during the afternoon. We actually see these maxima, these lift maxima taking place ahead of what could be a prominent shortwave trough that's taking place, and you're seeing these larger amounts of lift appearing. So that's represented by these yellows to oranges to reds and the purples to blues. So we're actually seeing that unfold. And this is 2 o'clock in the morning now on July 1st. So that's what this is depicting. So now we're going a little bit further. This is 5 o'clock in the morning. And this is 8 o'clock in the morning, July 1st. So we're seeing pretty large amounts of lift taking place here along what appears to be a potent shortwave trough. So this will join forces with that lift that we looked at previously with our surface convergence map. Okay, so checking our mid-level lapse rate. So this gives us some idea, an overview of how quickly temperatures are cooling at the mid-altitude. So this is measured at the 700 to 500 millibar altitude range. So the gray colors or greater represent steeper rates. And really what we're looking for are 6 degrees Celsius per kilometer or greater in terms of cooling. So we're not really seeing all that much. It's pretty modest cooling that's taking place during the pre-dawn period. This is 5 o'clock in the morning, July 1st. We're not seeing all that much across Eastern Ontario to Southern Quebec and much of the Northeast. It's pretty tame in terms of cooling. So this is not really driving that much instability. And as we go further, throughout July 1st, when the cold front becomes more important, we're not seeing still all that much. I mean, there is a little patch over here that represents approximately 6 to 6.5 degrees per kilometer, but that's about it. So it's pretty tame overall. This could still represent an area of maximized instability before that cold front finally passes through as it goes off to the east. So we'll have to watch around the island of Montreal as well for a possible organized multicellular family. So turning our attention to low-level lapse rates. So these are the lapse rates taken at the lowest altitudes. So approximately the surface to about 1.5 kilometers up, the 1,000 to 850 millibar altitude range. So the brighter colors represent the steepest cooling rates within those altitudes. So let's go towards July 1st, since that's the area of concern. So this is June 30th. So this is a good example of what a steep low-level lapse rate can look like. So these reds represent 8 to 9.5 Celsius per kilometer. So that's how quickly the air is cooling, the environmental lapse rate. And let's go into July 1st. So this is pre-dawn. Obviously, these are not as important during pre-dawn since there's no sunshine during these hours. But it is of interest during the afternoon, the late morning to afternoon period, and you're starting to see some larger lapse rates taking place in Eastern Ontario to Southern Quebec, and it's contingent with those breaks in the cloud deck that I showed previously. Okay, so this map shows us a representation of how much cloud coverage is taking place across the Northeast and Southern Ontario to Southern Quebec. So darker areas represent clear breaks, in this case large clear breaks, so this is a good example of what that looks like, whereas areas of white represent more continuous cloud coverage. So let's go towards July 1st and check on how much cloud cover would be present. So right now we're in pre-dawn July 1st. So at this point, it's not as important to gauge cloud cover. It's more important for the afternoon period to determine how much solar heating would be taking place. So right now, this is pre-dawn, as I mentioned, going into the morning and late morning, and now we are into the afternoon. You start seeing these gaps, these discontinuities taking place in southern Quebec, eastern Ontario, and much of the Northeast. So that tells us that the sun is able to get through by the early afternoon period, towards the mid-afternoon as well. Beyond the mid-afternoon, we don't have to worry so much because our principal lifting mechanisms will have passed off to the east. Okay, so this colorful map is a neat. Okay, so turning our focus to dew point temperature. So it's measured in degrees Fahrenheit, but really what this is showing us is how much humidity is in the air. So the greater the dew point, the greater the amount of moisture. And high amounts of moisture are represented by the shades of blue into purples, the purples being the highest. So right now we're having these really dark blues or dark grays if I'm colorblind, but anyway, that's what it pretty much looks like. So we're seeing dew points of around 68, 69 Fahrenheit around the island of Montreal, which is around 20 degrees, 21 degrees Celsius. That's very high humidity that's taking place during the mid-afternoon, June 30th, but we're interested in July 1st. So let's go straight to July 1st. Right now we're in pre-dawn July 1st, and you're still seeing these large amounts of humidity settling into the region, southern Quebec, eastern Ontario, most of the Northeast. So this is really going to be controlling the amount of instability that's taking place during the pre-dawn period. And we can go one time step further. This is around 5 o'clock in the morning. You're still seeing similar amounts of humidity. And then going into the later morning of July 1st, near lunchtime, even higher amounts of humidity. And then going into the afternoon now, lots and lots of humidity. So it's a really humid day, July 1st and June 30th itself. So we're seeing a lot of humidity settling into these regions, and that will be the primary factor for keeping instability fairly high. Parameter called CAPE, and it tells us how much instability is available at any given period of time. In this case, we are at the late evening of June 30th, so just gives us a good example of how much CAPE is present in these regions in the Northeast, Southern Ontario to Southern Quebec. But we're interested again in July 1st, pre-dawn to the afternoon period. So let's do that. Let's check on those particular time frames. So right now we are in pre-dawn, and you're actually seeing some pretty good instability, despite limited mid-level lapse rates, as I showed before. And of course, we're not getting low-level lapse rates since the area is not in sunshine, so that makes sense. But we are seeing a large amount of moistening that's taking place, so that is largely controlling the pre-dawn instability. Now let's go further to capture the afternoon to see what that looks like. And I mean, this is pretty good instability, around 1500 joules per kilogram. So that's not too bad of an environment to work with as far as instability is concerned to help generate decent thunderstorm families. But it's limited. You can tell it's not like particularly large instability either. This is because, again, the mid-level lapse rates are limited. We are spending a decent amount of the morning under cloud cover, so that is limiting more of a head start for solar heating. So that is controlling how much instability is taking place. So we're not seeing like a huge amount of instability, but there are pockets of up to 1500. It's possible to reach 2000 joules per kilogram if that sunshine factor becomes more important. For example, if we start seeing more breaks than expected during the morning, then that can start to encourage more instability generation. Okay, so this is a skew-T log P diagram from 2 o'clock in the morning in the west end of Montreal. So that's the sample point that I'm using here. So I wanted to show first a time frame from the pre-dawn period. So this is 2 o'clock in the morning of July 1st. Also show 5 o'clock and then at some point in the afternoon, just to give you an idea how the environment is changing. So this is ahead of that warm front at 2 o'clock in the morning. So this is 2 o'clock in the morning, July 1st. And really what you're seeing here is a mostly almost saturated environment, especially at mid altitude. See where this green line and this red line are converging. So the green line is our dew point temperature, starting at the surface, which is about 1,000 millibars, and that this plot shows us how that dew point is changing with increasing altitude all the way up to the tropopause and beyond. This red curve is our environmental temperature, and also doing the same, showing us how that's changing with increasing altitude. And then this dashed blue curve is our parcel temperature. And we can see some area of instability just based on how these curves are oriented. And you can see that based on that gap that's formed between this red line and this blue dashed line, right? So because our parcel temperature is to the right of this red line, it creates instability because there's more buoyancy in that the parcel temperature is warmer than the environmental temperature, which causes it to become buoyant. So anywhere in this gapped area represents instability, and we have about 850 joules per kilogram inside this area in terms of CAPE. So as far as CAPE is concerned, we do have that being generated. It's a pretty large amount for a pre-dawn period. So this is almost 1,000 joules per kilogram of MU CAPE, most unstable CAPE, taking place at 2 o'clock in the morning. So we're also seeing some decent shearing fields as represented by these wind barbs. So they're all pointed approximately in the southwest direction, and we're seeing that uh, in large part throughout the troposphere. So they're oriented in the same way. This is what we mean by unidirectional shearing field. So let's look at 5 o'clock in the morning. So same area, but this is at 5. You can see a larger speed shear component. So the winds themselves are starting to increase more with increasing altitude as represented by these wind barbs. It's nothing too significant, but it is stronger compared to what we saw 3 hours prior. And you're seeing a larger amount of instability. I mean, this instability is being distributed throughout a greater tropospheric depth. And you're also seeing some dry, near mid-level air starting to unfold as well. And now if we skip over to the afternoon, this is 2 o'clock in the afternoon, you're starting to see some much larger shearing profiles, speed shear profiles specifically. So still pointed in a southwesterly orientation, but with stronger speed shear values. So if you look carefully, if I can turn your attention to the 500 millibar altitude, you're starting to see these really strong 500 MB wind speeds, right? As represented by these flag-looking icons. And that represents some pretty strong winds taking place at those altitudes. And meanwhile, I mean, it's not a huge amount of CAPE, but it's similar to what we saw during 5 o'clock in the morning at almost 2,000 joules per kilogram. So it's distributed throughout a pretty deep tropospheric depth. And you're seeing some drier mid-level air to join up with this profile, right? As represented by the steeper decrease in moisture. So just based on the shearing profiles and this drying, this could actually improve the chance for some pretty strong winds coming from the gust front. So that's really taking place in this situation during 2 o'clock in the afternoon. So I don't expect a huge amount of thunderstorms in this environment since the lift isn't all that great by afternoon, but the ones that do develop will be able to become organized based on this profile. And their primary hazard would be the strong straight line winds, especially at a local scale, in terms of the gust fronts that do take place with the most organized multicells that form. And notice our dew point is still hanging on to the low 70s, which is something like 22, 23 degrees Celsius. So this represents very high humidity and is helping to fuel that instability factor still ahead of that cold front. So during the late evening of June 30th, that warm front is going to be located somewhere in this general area, okay? And then this will be the primary focus for thunderstorms in addition to that shortwave trough that's also accompanying this warm front. So as both these features start moving to the northeast, this will be the focus again for thunderstorm development. So ultimately, during pre-dawn, I expect thunderstorms to be forming in scattered fashion in general in these areas, coming in from eastern Ontario and upstate New York. And I do expect them to be forming in these general areas, and all of them following a trajectory like this, moving off there. So ultimately, this area I think will be prime for thunderstorm development during the pre-dawn period and even the late afternoon of June 30th. So one thing that does leave me a bit skeptical, though, is that the mid-level lapse rates are fairly modest, as I showed before. So I think this is going to temper the overall severity of these thunderstorms. So, and I think the number of thunderstorms altogether. So these thunderstorms, I think, will be mostly scattered rather than widespread, so I'm hesitant to go beyond scattered. Okay, so by the later morning and heading into the afternoon, that cold front now will be the primary lifting force that will guide thunderstorm development. And there's also another shortwave trough that is accompanying shortwave trough ST, accompanying this cold front. So this area here in particular, I think will be a prime zone for thunderstorm development. And some of these actually could be stronger than the ones that we saw during pre-dawn. So this will be an area of focus, I think, before this cold front ejects to the northeast. At the same time, the lift is not particularly huge with this shortwave trough and this cold front. During the afternoon, I do expect somewhat frequent lightning for some of these, so that would be one of the hazards. So ultimately, I believe that the hazards would be locally damaging straight line winds. This is for the afternoon situation, small hail, and some of these will be capable of moderate to frequent lightning, the most organized multicells that are able to interact with the heightened instability. And in terms of the pre-dawn period, I don't expect damaging winds necessarily, but some of these thunderstorms, even though I mentioned that they generally are non-severe, some of these will be capable of moderate lightning frequency, mostly capable of significant water accumulation locally. Wind shear profiles. So remember, during the afternoon, those wind shear profiles are much more magnified, and we saw them increasing in speed at the 500 millibar altitude and surrounding altitudes, moving pretty quickly. So we saw wind barbs with a flag like that. So that indicates some pretty fast wind speeds moving off in this general direction to the northeast. So these will be faster moving thunderstorms as well. And I think the drier air at the same time will also amplify the downbursts that we're going to see with some of these thunderstorms. So I think those pre-dawn thunderstorms will be especially capable of significant water accumulation since the rainfall would be heavy with some of these. And that water accumulation hazard would be mostly prominent for areas that are repeatedly affected by these early morning thunderstorms. So if you made it this far, thank you very much for your attention. I really appreciate it. And if you enjoyed this video, if you found it insightful, again, I encourage you to subscribe so you don't miss out on upcoming videos. And until then, I will leave you with these playlists. They feature my forecasts in general, previous forecasts and forecasts to come, and footage from the Montreal area in terms of previous thunderstorms. So feel free to check those out. Until then, I will see you in the next video. And once again, thank you very much. Cheers.